Welcome back to AERO 3170, Aviation Safety, Presentation 12 on Textbook Chapter 12 about Managing Safety. In this presentation, we'll cover the technical era, Total Quality Management, or TQM, the golden era of aviation human factors, Amendment 33 of ICAO Annex 6, the four pillars of safety risk management, and the difference between a risk and a hazard, and we'll end up with a description of the risk management process. So what era were the decades of the 50s and the 60s in the development of modern safety principles? The technical era took place during the decades of the 1950s and the 1960s, and it was called the technical era because it concentrated on improving technology, technical factors that contributed to aviation safety. Then during the 70s, the Japanese adopted TQM, or Total Quality Management, in the manufacture of autos and electronics. TQM was focused on teamwork and employee involvement in improving the quality of products, manufactured products. It was developed by W. Edward Deming and Joseph Juran. So how did total quality management influence the development of aviation safety management? In the 1970s, the emphasis shifted from the technical era to the human era. Crew resource management, or CRM, line-oriented flight training, or LOFT, were more focused on the human element of safety management. ICAO, or the International Civil Aviation Organization's Safety Manual, the Safety Management Manual, called the period between the mid-70s and the mid-90s the golden era of aviation human factors, because it was during this time when the focus of aviation safety switched from technical issues to human issues. So what did ICAO Amendment 33 of Annex 6 require operators in member states to do? Amendment 33 of ICAO Annex 6 set the stage for safety management system awareness on an international basis. Amendment 33 of Annex 6 required operators to implement a safety management system. ICAO requires member states and their operators to implement an SMS, safety management system, that at a minimum identifies safety hazards, ensures remedial action to maintain acceptable levels of safety, provide for continuous monitoring and assessment that aims for continuous improvement. And it's important to note, though, that ICAO did not require SMS until 2006. So what airline accident resulted in the changes that are now required in safety management systems? The Colgan Air Flight 3407 accident near Buffalo, New York, resulted in a public law known as Public Law 111-216, and that required all Part 121 air carriers in the U.S. to implement a safety management system, which should be based on the ICAO framework. What are the four pillars of safety management systems in the United States? The first pillar is called safety policy. The second one is safety risk management. Third is safety assurance. And the fourth is known as safety promotion. Under the SMS pillar, known as safety policy, the responsibilities of the accountable executive, who is the leader of an organization, is to provide clear safety objectives and methods and processes that the organization can follow to meet their safety goals. The second component of the safety management system, safety risk management, involves identifying hazards that could cause death, injury, or damage, and assessing the risk to determine the need for mitigation. Mitigation means reducing the risk in some way. The SMS pillar, known as Safety Risk Management, provides for identifying hazards and then assessing the risk to determine whether or not there's a need for new or revised risk controls. There may be some hazards that don't require any mitigation. They're acceptable. Even though they were identified as a hazard, there may be no need to implement any new or revised risk controls. Which brings us to the acronym ALARP, A-L-A-R-P. ALARP stands for as low as reasonably practicable. Under the Safety Risk Management pillar, risks should be controlled to a level as low as reasonably practicable. This figure is from the ICAO Safety Management Manual, and it illustrates the different levels of risk. The top level is called intolerable. These are risks that are unacceptable at any level. And in the middle, you have a tolerable region. This is risk that is acceptable based on mitigation efforts, based on risk controls. And a cost-benefit analysis is required to make that determination. And that's where the term as low as reasonably practicable comes from. At the bottom, you see the acceptable region. These are the risks that are acceptable as they currently stand. There is no need to mitigate them. So what is the difference between a hazard and a risk? Are they different? Are they the same? A hazard is a condition or an activity, some potential to cause death, injury, or damage. A risk is the assessment, which is expressed as a probability and a severity of the consequences of that hazard. So we can express risk like a mathematical formula. R equals P times S, or risk, or expected risk, per unit of time, equals the probability that a hazard may materialize, times the severity of the consequences, or the effect. As an example, we can look at the hazard of thunderstorms. What is the risk of a thunderstorm? If we view it as an equation, probability times severity, what is the probability of a thunderstorm? And what is the severity? Well, the severity could be quite catastrophic if you flew into a thunderstorm. But the probability depends on the time of year. Probability of a thunderstorm in the winter months in the northern part of the United States is very low. So at that time of the year, the risk of a thunderstorm is low. But in the summer, when thunderstorms are quite frequent, the risk could be quite high. In order to assess a risk or classify a risk, safety risk management systems use what's called a risk assessment matrix. And you can see a simplified version of this in this slide. On the left-hand side, you have likelihood, and at the top you have severity. Likelihood is classified as probable, occasional, remote, or improbable, and severity is categorized as either catastrophic, critical, marginal, or negligible. Depending on the likelihood and the severity, the risk is assessed as either high, serious, medium, or low. In the example that I just used concerning thunderstorms, in the winter months in the northern part of the United States, thunderstorms are improbable. But if an aircraft were to encounter a thunderstorm, the severity would be catastrophic. And so because it's improbable, even though the severity is judged to be catastrophic, the risk is a medium risk, according to this matrix, and may not need mitigation. So what is the purpose of risk mitigation? The purpose of risk mitigation is to either eliminate a hazard or reduce the severity or likelihood of the hazard to an acceptable level. There are 5 hazard control strategies that are important for you to remember. The first one, if at all possible, is to eliminate the hazard. Get rid of it. The second one is to reduce the hazard. The third is to employ some sort of safety device. We could also use some sort of warning system or alert system. And we could also change safety procedures or include new procedures to mitigate the risk. When the risk assessment is complete and the controls are put in place, the safety management system then shifts to the third pillar, and that's known as safety assurance. Safety assurance provides feedback on how the safety risk management process is performing. If it's performing well, then there should be some positive feedback. If there's still a problem, we should be getting negative feedback. So it provides feedback so that we can determine whether or not the controls that we put in place are working. It's important to remember, though, that whenever you make a change, doesn't matter what kind of a change you make, you could be inadvertently introducing a change that could cause another problem. New procedures should be evaluated and verified by safety risk management process to make sure that it doesn't have an effect on other processes. The fourth and final pillar of the safety management system is safety promotion. So what is involved in safety promotion? Well, first of all, it should be continuous. Promotion of safety should never stop. Second of all, it should include a formal safety training program, both an initial training program and a recurrent training program. And it should include safety communications like safety meetings, safety newsletters. And it's important to remember that SMS, safety promotion, encourages all employees to have a role in safety. Safety promotion encourages all employees to have a role through what's called a non-punitive safety culture, known as just culture. A company with a just culture is one that encourages employees to report hazards so that they can be addressed by not punishing employees for reporting those hazards. In a company with a just culture, employees don't have to worry about being fired for reporting a safety hazard or a safety concern. This encourages all employees to report hazards so that they can be addressed properly. Well, that's the end of safety management systems. The next presentation 13, we'll take a look at aviation security.